Hello, everyone, and welcome. It is Wednesday, the 11th of September, 2024, and we are gathered with the knowledgeable-eyed crew, and my beautiful wife again has slaved away for the last week putting together this MetBull update for you guys. Just so you know, the MetBull update is the update of everything put in the meteoritical bulletin database. Once it's in that database, it is a real meteorite. It does not exist in our book, in our opinion, unless it's in the MetBull. So these are now the meteorites that have been added to the database recently, and Sue's going to give us all the information about them. Sue, take it away, please.
Thank you, Topher. Okay, so today we're going to review meteorites that have been approved and published in the MetBull during the months of July and August of 2024. And in total, that's 948 meteorites. So we're going to start where we always start, and that's in Antarctica.
Yeah, I'm glad you're doing as well as me.
Oops. Okay. So before we jump into the new classifications, we're going to review the reclassifications. So we had 49 reclassifications, and they were all in the Yamato dense collection area, and all but one were from the 1970s. And for the most part, these were really basic reclassifications, reclasses such as an H4 to an H5. So nothing too controversial or any major significant change, just really simple adjustments. So next, we're going to move to the new classifications. And for the new classifications, there were 489 meteorites. And here I'm showing the dense collection areas. And then on the next screen, you're going to see all of the numbers of the classifications. That's really small. Sorry, so you'll have to zoom in. But the ones that are in bold are ones that have 25 or less classifications for that particular one. So next, we're going to go to the expedition teams that you see here. Some of them we have talked about before. I try to talk about what a country is doing in Antarctica each time that we have a MetBull update. So Belair, the first one that you see there, is related to Belgium. NIPR is one that we talked about last time, and that's the National Institute for Polar Research, and that is the team from Japan. The next one you see there is a collaboration between the Japanese expedition team and a Belgian team. And PNRA is the team from Italy. And then lastly, I think it should be obvious, is a collaboration between Italy and South Korea. So for this time, we're going to talk about the collaboration between Japan and Belgium. And they've done a lot of work together. So Japan and Belgium have been collaborating on meteorite searches in Antarctica since about 2009. And they especially are known for the Samba mission. The Japanese expedition has been searching on the Nansen ice field since about the late 1980s. There have been about 2,200 meteorites found in this area, and including a large number from the known as Asuka, and that's a dense collection area, but also the name of one of the Japanese bases in Antarctica, and that accounts for about 6% of all Antarctic meteorites. So as I said, the Japanese were joined by the Belgian team in 2009, and their missions have been to search that Nansen ice field area, and that's split into 3 areas: Nansen A, Nansen B, Nansen C. The joint team searched the Nansen A ice field in 2010, 2011. And they mostly found really highly weathered meteorites that weighed on average about 30 grams per meteorite. And then about 2 years later, in 2012 to 2013 season, they searched the Nansen B ice field, and they found much less weathered meteorites, and the average weight went from 30 grams to 175 grams per meteorite. So I thought that was really interesting, and I searched a little bit about that and started reading a paper. I'm not going to go too deep into it, but if you're interested in finding out more about the disparity between the ice fields, you can read a paper. It's called Unraveling the High Altitude Nansen Blue Ice Field Meteorite Trap and Its Implications. So interesting stuff. So let's cool. Move on
I want to jump in before we move on. So I thought this was a really cool picture right here. we normally don't think of Antarctica having this many rocks all together, but this is what they're going for. They're going for these natural collection areas where the rocks are collected naturally. But what got my interest is if you look at these rocks, they actually have wind-blown lines in them, much like regmaglyphs, and that's them becoming ventifacts by getting the ice and wind and constantly eroding at them and carving these lines in them. So I thought this was a really cool picture to see that in.
Yeah, definitely. Oh, and I should also mention that the joint collaboration between Japan and Belgium, I think it was in 2013, they actually found one of the largest meteorites that have been found there for the last few decades. And I believe it was like 13 kilograms.
Wow.
I think he's posing with it right there,
Yeah.
which I'm sure if we were down there, we'd all want to pose with it.
Yeah, well, you know what? Antarctica is cool and all, but we can't have them. So tell us about these.
And speaking of that, so now that we've looked at the meteorites in Antarctica, now we can talk about meteorites that you can actually own. And that leaves 408 meteorites to cover. So first, we're going to talk about confirmed falls. So we had 2 new falls and a find possible fall, and then 1 reclassified fall. So this is unusual. I don't usually do this, but I'm actually going to talk about a meteorite that we don't have any pictures of. There weren't any in the MetBull, and there weren't any on, I couldn't find any on Facebook really or on Google, but we definitely have to talk about it still. And that is Ankazomena, and that fell in Madagascar. So I wanted to see, raise your electronic hand if you know any other meteorites that fell in Madagascar. I'll give you a hint. There's only 2 others. Does anyone know?
There's only 3 meteorites classified from Madagascar, and they're all witness falls.
No hands raised?
I knew one of them. And
Topher actually did know one of these. He didn't even have to like think about it. He knew off the top of his head.
Benenitra is the only one that I knew of.
Correct, Benenitra. And the other one was Marimandia. Okay, so Ankazomena, like I said, fell in Madagascar. Now, the MetBull shows it, the official date as 2018, and I'm guessing that just is because they can't absolutely verify with proof the actual fall date, but it did fall on July 30th, 1977. So they say in the MetBull, it fell around lunchtime. It was a stone, fell very close to a laborer working in a field, and it gave him a great fright. The event of the fall was reported in a French newspaper called the Le Provençal a few days later. That laborer took the stone and to his employer, Mr. Upton, who kept it without giving it really much of a thought until much later. His son heard about meteorites on a radio program, and he contacted collector and dealer Luc Leben. And so it's a single stone fall. The cut surface reveals large chondrules and millimeter-sized CAI set in abundant dark matrix. I wish we could see it. So if you're watching and you do have a picture of it, feel free to share it with us. We'd love to see it.
Absolutely.
So next, we're going to go to the Prairie Girl Allison, the one and only Conversation with Hunters. She is going to talk to us about Addison. So let's throw it over to Allison.
Awesome. Thank you, Sue. On October 12th of 2012 at about 5:30 p.m., a meteorite fell in Alabama near the town of Addison. It was visually reported by many people, but it was also audibly reported by about a dozen people. There was a sonic boom reported. And as we know, a sonic boom is often a good sign or even associated with fragmentation. So what's neat about Addison, though, is that signatures of this falling meteorite were seen on weather radar. And weather radar data can give us a lot of information about a meteorite, about where it landed, about approximately what size it was when it entered the atmosphere or even when it landed on the ground, and about maybe how many pieces we're looking to find. And the Addison Fall did in fact fragment extensively, and it produced copious amounts of small meteorites that probably very few large stones. It's kind of impressive to me, honestly, that more of this fall wasn't found and recovered. I think only maybe 2 stones in total. And but the thick foliage on the ground in Alabama made hunting really difficult, and the majority of it may have fallen in a national forest nearby. It is illegal to take meteorites out of a national park or a national forest without a permit. There were some individuals from NASA who were allotted some permits to go in and look, and they still were unable to obtain a lot of this fall, even though there should just be, you know, lots and lots of little pieces out there and we know where to look. So I know it's not the topic of today, but I do want to take advantage of this conversation and say that even in the best of circumstances, with the best of information, and even in the right place with all of that information, you're still not guaranteed to find anything. It's a hard sport.
Yeah, I love the way you approach that. And I'm going to take it one step further as an invitation to our viewers out there. We have a lot of rock hunters that view us. If you are in here, let me put the map back on the screen. If you are near Decatur or Huntsville or Birmingham, make a weekend trip, go camping, find out where this is, do some research, find the strewn field location, and hunt on a target-rich environment. They might not have been found yet, but they're still there. So if you're going to hunt somewhere, you might as well go somewhere where you know there's a high probability that there's meteors or meteorites. And you're not really going to get to the Sahara Desert, or Alabama is the second best. So, Allison, thank you very much. Really appreciate your check-ins all the time.
Yeah, thanks for having me. That was a fun one. I liked it.
Sue?
Thanks, Allison. I can always count on Allison to help me out.
Yeah.
Okay, so next we're going to go to the find possible fall. And so, like the name says, it was probably a witness fall, but just not enough documentation to make it a confirmed fall. So I'm not going to butcher the name of this one because it could be pronounced in a funny way, but I believe it's Assedreme and 001. It's an H5 chondrite found in Mali. And this one was classified by Carla G. And the first picture that you see was submitted to the MetBull by Carla G. And Topher believes he can pick his picture of Assedreme out of these. I thought he was joking, but he was very serious.
No,
so
it's this one. I don't know if you guys can see my cursor up, but I'm pretty sure that's my piece right there.
So I'm actually going to turn it over to Topher because he was gifted a piece of this meteorite and has a lot of awesome pictures of it. So Topher, take it away.
Yeah, it's not very often that I can pick my piece out, but as soon as I saw this picture, I'm like, well, I know it's a small one. I know what size it is. I know it's cracked in half. I think that's it. Tell me if you guys agree, because it's not this one. It's too big. Yeah, I was really fortunate, as I shared with the crew. I don't know if we recorded it or not, but I shared with the crew that I was gifted one of these meteorites freshly after the fall by Preston Allen, who I believe is the main mass holder, or one of the main mass holders, specimen holders at least. He gave this piece to me when it was still under the working name of Selma. So that was the location it was closest to, was Selma. Since then, they've done some more research or trying to document the actual fall and witnesses to the fall, so they could literally have it put in the MetBull as a witness fall, but it's not. So I know it was witnessed to fall on, let me see here, on December 3rd, 2022 at 2 p.m. So we're pretty precise about when, but the problem is they went out and hunted for it and they weren't able to recover the samples for months. So that adds to the difficulty of getting it classified as a witness fall. Obviously, if you go out there the next day and you find fresh pieces, that's a different story. But this is a really good, interesting piece right here because it's super fresh. It just fell, just came from space, and it's been safe ever since. Hasn't been rained on, and it's beautiful in the interior. Oz Backman, a crew member, posted his sample today online, or yesterday, and it's beautiful. It has beautiful contraction cracks on it, but it's so fusion crusted he couldn't see the inside. So I was able to share with him what his meteor looks like on the inside. Beautiful. Look at the size of those chondrules. 3D chondrules sticking out. And I think I have a brief video. Yeah, so thank you very much, Preston. This was super generous of you, man. Really appreciate it. So now that you know what mine looks like, you can go back on the main picture and see if you agree with me that I actually picked the right one or not. But yeah, I'm very fortunate to have some very generous friends that are connected. As soon as something like this happened, I had a piece gifted to me, and I'm really appreciative of it. It looks like I need to read the write-up. I haven't read the write-up yet, but there's a lot going on there as far as crystals go, as far as non-chondral matrix. So, Sue, back to you.
Okay, now we're going to discuss the one reclassification. And this was also it was a witness fall in Poland. There are about 25 classified meteorites in Poland, and I think, no, 26, and half of them are witness falls. So this one was an L5, and it was reclassified as an L4-5. And what that is an ordinary chondrite from the L group that is a breccia of type 4 and type 5 components. So if you look at them, and there you can see the pieces are really small because there's only about 350 grams of total known weight, and as a witness fall too, in a European country, obviously 350 grams don't spread that far. But I wanted to have Mike chime in here, our on-staff geologist, and explain when you're seeing things in the MetBull as an L4-5 versus an L4/5, and what the difference is in those classifications.
Sure. Yeah, you'll see the dashes, and you nailed it right, like you said. So that's an L4 -5. So there is type 4 lithology in there, and also type 5 lithology. So you can think of a dash as an and. So that's type 4 and type 5 in there. Whereas a slash is a transitional. It's kind of in between the two. So there may only be one lithology in the rock, and it's all that material, and it's kind of sitting right on the fence between 4 and type 5. Same thing. You'll see that you'll see like an H/L, right? So it's sitting between the H and L as far as the characteristics of the stone. You will always see the numbers when it's a slash. They're always next to each other, right? Because it's only between two petrology numbers. Whereas with the dashes, you might see like a 4-6, because there could be 4, and 6 in there, or there could be 4 and 5 and 6. It could have all the components in between. So you'll even get things all the way up from a L3-6 or L3-7, because they have multiple different lithologies in there of the different petrology types. Great question.
Thanks, Mike.
Great explanation too. Thank you, buddy. I was just looking at the fusion crust, and before I kick it back to you, like, that is some beautiful little fusion crust. If you're going to have a sliver of that, you might as well have that piece right there.
Oh, for sure. All right, so now we're going to discuss locations. So we'll start here in the good old United States. We have 2 finds in the United States. And so we're going to talk, the featured one we're going to talk about is Misfits Flat 003. And I think this is a really cool story. It kind of goes back to what Topher was talking about when we were talking about Addison, about, you know, if you're a meteorite, if you're a rock hound and you want to find a meteorite, do it intelligently. Do your research. Don't just go outside and just kind of search randomly. And that kind of is the story behind the person that found Misfits Flat 003. And I think it's a really actually cute story. It's another meteorite couple like us, Topher.
Yeah.
So this is, the finder was Cheryl Harlan and her husband, Scott. So he took some of these pictures. She took some of them. So she found 003, and that was the one that was recently published. But guess who found Misfits Flat 001 and 002? Scott found those. So between the two of them, they have their name in the MetBull 3 times. And so far, they are dominating this dense collection area. And then Cheryl told me I could share this with you guys. So she does have a chronic illness that keeps her from hunting for long periods of time. She said usually after about 15, 20 minutes, she is absolutely exhausted. So her husband has been searching for meteorites, I think a little bit more extensively than she has. And so obviously Nevada is a great place to look for meteorites. So he got his maps out, he did his research, and he kind of calculated based on like where other meteorites have been found, looking at the terrain and everything, and decided, let's look here first. And so they parked their car and she found her meteorite within 15 minutes, only 200 feet from her car. So they are a great meteorite hunting team. She spoke of her husband very fondly. So I thought that was really adorable story of how they pretty much own this dense collection area. So if you do the research and you do the work, you can actually, find a meteorite. It's very unlikely for the average person, but I think that they have some experience and I think it's really cool. So, and here we can see the thin section, which I thought was really pretty. And I did ask them, like, maybe you could let Marissa borrow it. And she's like, oh, Chris Hurd has it at the University of Alberta, but they said on their next find, they're going to send it to Marissa first because they loved her art. So I introduced them to it and they checked it out. So I thought that was really cool. So
That's
congratulations, Cheryl, on your first entry into the MetBull.
Yeah, congratulations as well. And Sue, that's a great story. I know you do like I said before we start recording, this is a lot of work putting these together. You put multiple hours, a full work week into these MetBull updates and reaching out to people and making friends with them and learning their story and telling their story and sharing their meteorites. That's what the MetBull update is to me. This story just encapsulates it fully. So thank you.
Thanks, Son. All right, so now we're down in South America. We had 94 entries into the MetBull. They were all down in Antofagasta, Chile, in all the established dense collection areas that you see there. So moving over to the other side of the hemisphere, we have two in Russia, one over on this side, Borgia, which is a main group Pallasite. And then on the other side of Russia, we have Algino, and that is an L3 chondrite. So then moving over to China, there were 25 found in Xinjiang. We had 2 found in Nea Mongol. We had 2 found in the Gansu province and 4 in Qinghai. And then over to Mongolia, we found Khatgal, and that is a Pallasite-ungrouped, and that is the 13th Pallasite-ungrouped in the MetBull. And so that was a 3.5 kilogram flat iron mass with many small pits and many yellow and green crystals. You can go ahead and show some of the pictures, Topher. This is a really interesting looking meteorite. So the polished and etched section shows sub-rounded polycrystalline silicate aggregates with chromite on their grain boundaries and rounded green silicate grains set in a matrix of polycrystalline metal of irregular martensite fields with relict micro-Widmanstätten pattern. Wavy camsite bands separate the metal crystallites. Chromite occurs adjacent to the silicate grains in the metal phase of the surface.
That is too cool.
It's really neat, isn't it?
Yep.
That's unlike any Pallasite I've ever seen before.
And that's why it's ungrouped, but it's beautiful.
Yeah. Thank you, Allison.
Oh, thank you guys for sharing that.
Yeah.
And I did tell Topher, I looked at, I didn't share it on here because I didn't know how to explain it, but I did look at the oxygen isotope chart for this one. And it was really weird because it showed the Pallasite main group and then below it, Mesositerites. And this one actually plotted way closer to the Mesositerites than it plotted to the Pallasites. But I don't think I've ever seen an ungrouped Pallasite necessarily. But yeah, it'd be really good to maybe do a deeper dive into some of these oxygen isotope charts sometime. But yeah, this is definitely a really unusual Pallasite. Yeah. I think the metal looks really cool.
The first thing that is striking to probably all of us is the amount of metal we're seeing. Usually Pallasites are a 50-50 mix. You never really see this much metal unless it's almost like a semchen, was considered an iron at its first finding. Wow, 3.5 kilos. I just need a few hundred grams.
All right, so over in the Middle East, we had 11 in Iran and 5 in Oman. One of the ones in Oman is an Enstatite chondrite, which is one of 13. And then we move on to Northwest Africa. Now, these are the ones that are just Northwest Africa, no countries associated with them. And then on the next screen, these are ones that are found in the same area, but they actually have a country associated. And coming in hot, Morocco with 71 classifications in the last 2 months. Then we go down to South Africa. Now you can see there's Ankazomena, which we discussed earlier, the witness fall in Madagascar. And I did plot it there. That's exactly where it fell. And then over in Namibia, we have 9 more entries. And those were entries in the 2 main dense collection areas that have recently been established in that country. And that's Maribib, which we've looked at on a previous MetBull update. And then Ruikop, I believe that's how you say it, is another dense collection area that's been started recently. So now we're going to jump into classifications.
Yeah,
so first,
class is over.
Yeah, I didn't spend too much time on geography. All right, so as always, we jump into achondrite first, and we're going to look at the achondrite numbers. Now, and the featured achondrite that we're going to look at is actually the one that's most rare on there. Does anybody have an idea of which one of those classifications is the rarest on this group? Any takers? Come on, guys, don't be afraid.
Winanite?
Acapulcoites.
Achondrite-ungrouped.
Enstatite, Achondrite-ungrouped.
Yes, correct. The Enstatite Achondrite-ungrouped. There's only 6 of those.
Wow.
So this we're going to look at Check 004. This one was brought to us by our buddy Yang, and so this has affinities to chondrites based on the silicon content of metal. The presence of 2 types of coexisting enstatite with systematically different enstatite contents is the anomalous feature in this specimen. To me, it looks like a mesosiderite, kind of.
It looks like a mesosiderite pallasite winonite. Wow.
Yeah, interesting stuff.
82 grams single stone. I think there's a video too.
There are 2 videos, I believe.
Wow, you can tell it's absolutely dense just on the outside.
Yeah. Pretty.
Oh my God. Wow. This is Check 004.
Yes. I think there's another video.
Yeah, we're on Check 005 or 8 or something like that. We're past 8.
Yeah, there's more of them than, but this is 004.
This one took a while to classify. That's why it's out of alignment with the other ones, because it took so long to classify.
This one was submitted like 3 years ago, I believe.
Yeah. I wonder if this is the same video. Oh no, this is a nice close up.
Isn't it just glassy looking too?
Yeah, I wonder if there may be a coating on it. I'm not sure.
Yeah, the exterior is really glossy too.
Yeah. Wow. Wow. Interesting stuff, guys.
All right, so next we're going to move to ATD meteorites, and those are the vestoids. So if you're watching a MetBull update for the first time and you don't know a lot about meteorites, ATDs are from 4 Vesta, and they are the Howardites, Eucrites, and Diogenites. And for our featured ATD, we're going to look at a Eucrite-mmict, and that's NWA 16525. This one was brought to us from Jason Whitcomb. And we're going to
go right ahead.
All right. Let's see. So we're featured. I was like, what the hell happened? All right. For our featured HED meteorite, we're going to look at a Eucrite-mmict brought to us from Jason Whitcomb. So Jason said at least one other person that he knows got a bunch of this stuff early on and prepared samples for classification. Now, Jason said he did wait a bit to send it in, and he kind of missed out on the boat on getting it added to the Jakara 001 main mass, which this one is a pairing of. So once again, he said he was left out of the cool club, but Topher and I don't agree. Jason's super cool. So Jakara was published, and Jason had this mostly through the classification process at that time. And in an effort to follow best practices, Jason asked in one of the groups what folks thought he should do. So two of the main mass holders said, go ahead, you can use Jakara 001. That's fine. Some folks said that following through on the classification and just informing Dr. Hurd that it was likely paired was the best thing to do. So after all, the more analysis was properly done on the material, it did finally get added to the MetBull. So while it does have its own classification, it is officially a Jakara 001 pairing.
Wow, some of these pictures, I'm gonna go back to these pictures. I don't like those videos as much. We're gonna get to some. I want to go through these a little bit. That one is amazing right there. You literally see the bubbling in the melt. One thing that Jakara is known for, if you're lucky, your piece has some of that. Also, this is some of the best crust in the Jakara 001 game, kind of like the crust I revealed under my caliche last week in my Jakara. These little ugly rocks, they look like they're just like they're going to be ugly, but then you look at those bubbles. When you finally do get them cut open, this is the most striking stone right here. I really hope he held on to this one, because it literally shows you all the, not all, but a lot of the different lithologies that you see in Jakara. Jakara 001 is a Eucrite-mmict breccia, but there's 3 tons of this stuff. So there's a lot of diversity, disparity that you can find in samples. This piece shows the best of everything. You have the white, almost lunar looking breccia going to a full rivers of melt. That's another one on the bingo. You have rivers of melt with isolated pebbles in here that are melted but not totally melted. That's a beautiful, beautiful piece, man.
Thanks, Topper. All right, next we're going to go to lunars and Martians, and I have a few different featured meteorites to share with you. And so there are a lot of rare meteorites on this list. I will say lunar basalts, there are 30 of them now, but we had one added. And then lunar troctolitic northsite, there are 14 of those. So the first featured meteorite we're going to look at is NWA 16660. And this is one that was brought to us from Jasper. This is a feldspathic classed bearing impact melt breccia. The matrix is fine-grained, recrystallized, and glassy. And the class include monomineralic fragments of plagioclase, olivine, orthopyroxene, melt rocks, melt breccias, a northacitic material, and minor occurrences of magnesian noritic class. It's a very interesting meteorite.
It is super interesting, and like it doesn't even mention, or maybe it did, but you didn't focus
the
on
big vesicle.
all these vesicles everywhere in this piece. It's truly unbelievable.
Oh,
See,
right down to the left near the bottom.
Yeah.
Yeah.
This, even in this slice right here, you have this beautiful vesicle. I mean, it's a perfectly round one, pretty much. There's vesicles everywhere. You can definitely see it's a melt. Wow. Stunning. We got to be careful with vesicles, man. They're going to be the downfall of meteorite wrong. I'm telling you right now. Yeah. This is why the science needs to kick in once an educated eye looks at something. When I look at this, I see some things that I like. I see some things that I don't like. And it's a freaking lunar meteorite. So it is necessary to get scientific testing done when you have a questionable sample. But the very first thing you can do before jumping into testing an oxygen isotope is just cut into it and see what it looks like. Now that you see the inside, now I have a little bit more idea about it. I'm not just basing it off the outside. So sorry, but I didn't mean to take over your MetBull.
I love when you have input and insight into these things, for sure. Especially since we don't have Daniel on tonight.
It's just like I don't pretend to be an expert on everything. I don't know everything. But if someone sent me this picture right here and asked, "Is it a meteorite?" I don't know if I would pass that test. I think I would fail that test. So there's always room for improvement, and let's not be cocky, but let's listen to science. That's my message, if I had a message.
And Topher, how many lunar meteorites have been found in the United States?
Oh, in just the United States or all North America?
All of North America.
And South America too?
Yeah.
Oh, zero. Zero.
And I'm not making fun of the people that reach out to us claiming to have the 30-pound lunar in their backyard, but like it would be really unlikely. We still have not found a lunar meteorite that's been classified by science on this entire side of the world. So something to think about.
It has a lot to do with our environment over here, but all right.
All right, so we're going to move on to NWA 16784, and this is a lunar troctolitic melt breccia. So before this period for the MetBull, before July and August, there were only 3 of them, and we just had 2 more classified. So this is one of them. This was brought to us from a Yang Shencheng, our buddy. So this sample is a polymicted breccia. It's comprised of millimeter to centimeter sized lithic clasts, such as anorthosites, troctolites, pink spinel troctolites, impact melt class, and mineral clasts, such as isolated grains of olivine set within a dark melt matrix containing some observable vesicles. So a variation in the matrix matrix texture was observed across the sample with at least 2 noticeable textures. A texture that was comprised of olivine and pyroxene, quite polytically enclosed within a plagioclase rich melt, and a texture comprised of olivine grains, surrounded by radiating laths of plagioclase and minor pyroxene. And it's just a really interesting looking meteorite. I love that big dark class there.
Yeah, it's super interesting. You said that this had pink spinel.
Pink spinel troctolites.
Troctolites, interesting. I wonder if that's what we're looking at here.
And this was classified by our buddy Daniel Sheikh at Cascadia Meteorite Lab.
Oh, super interesting. Yeah, congratulations, Yang. That's a nice one.
Yeah, for sure. Right, so the next one we're going to look at is, I'm probably going to butcher the name, but Dayet L-003. And the main mass holders are Matthew Stream and Mark Lyon, and they lovingly refer to this meteorite as the brain. And when we show you the video, you'll see why, because it looks like it has a brain in it. But this sample is a polymicted breccia comprised of millimeter to centimeter size lithic class, sub-millimeter and millimeter size mineral class, all set within a fine-grained matrix. Due to the brecciated nature of the sample, containing the larger class of larger than a centimeter. So some regions in the sample display crystalline melt breccia matrix, while other regions display a fragmental matrix. So the lithic class lithologies identified include anorthosites, troctolites, impact melt class, and dunites. Mineral class lithologies identified include irregularly zoned olivines, pyroxenes, and chromium spinels. Look at that brain right there.
Yeah. Wow. Nice.
All right, next we're going to look at NWA 16557, and this one is a troctolitic melt rock. This one is one of only 3 classifications. This one was found Northwest Africa in 2023. It is a very fine-grained microbreccia consisting of sparse lithic troctolite class and mineral grains of olivine, anorthite, and chromite within a dominant ultra-fine-grained vesicular matrix containing the same mineral phases such plus pigeonite, subcalcic augite, trolite, camacite, and taenite.
Wow. One of six.
One of three.
One of three.
Yeah.
Troctolitic melt rock. So that means
I would not have guessed that as a lunar.
yeah.
It's so dark.
The troctolitic melt rock, it means the entire rock, the composition of it is primarily troctolite, and it's been melted due to heat or shocking, causing the entire matrix or whatever to come together in one cohesive melt, rather than feldspathic breccia or fragmental breccia, where each of these components are smaller and constituents within the bigger piece, if that makes sense.
Well, yeah, exactly as like the write-up says, it's a very fine-grained micro breccia. And so you can see that, and then it has really sparse class, which obviously you can see as well.
Oh.
All right, so now we're going to go to chondrites, and first we always look at carbonaceous chondrite. So this one I thought was really interesting. The one I decided to do as the featured carbonaceous is the C3-ungrouped, and it's one of 35. And I thought it was really interesting because the total known weight of NWA 16288, it's only 32.6 grams. And I noticed like something I don't normally see. I see a lot of like one classifier or two, but I don't usually see three different classifiers and their institutes looking at something, especially something this small. So of course, Topher and I looked at the write-up together and read through it, and it was definitely interesting. So it described that this meteorite has more matrix than a CO3 chondrite, is texturally somewhat like the CM chondrites, yet the phyllosilicates are absent. So it is a C3 chondrite, but it's not a CV3. It's not a CK3 or a CL3, which all have much larger chondrules and less matrix. And then I also saw that they use powder X-ray diffraction on this. I don't really know what that technology is, but I don't see that in a lot of the write-ups. And then in relation to that, I believe it said a single grain of aluminum titanium diopside was observed and analyzed, and that implies the presence of CAIs. So we just have this one picture, microscopic picture, but I just thought it was an interesting write-up.
I think you nailed it. When a lot of people have difficulty getting their material into a lab to get it looked at, here you have three of the best looking at the same material, all partnering together to work together. This is obviously of interest to science. So these are the ones that we're striving to understand a little bit more of. So pretty interesting. I'm glad you included this one, even though we don't have a picture of the actual meteorite.
Yeah. Right, so we're going to look at ordinary chondrites, and what we always look at first are the miscellaneous chondrites, and these are the ones that are not L's or LL's or H's. These are the Enstatites, the OCs, and the Rumurutis. And for the featured miscellaneous chondrite, I chose a Rumuruti, and this one is NWA 17004, and this one was brought to us, another one from Jasper, so thank you. He's pretty new to the MetBull update, and he's been giving us a lot of great entries, so I really appreciate it. This one didn't say too much, but it's a dark grayish fragment that was partly covered with fusion crust. The meteorite shows a dark gray interior as well. It's composed of well-defined, mostly rounded, separated chondrules, often compositionally zoned mineral fragments set in an abundant matrix dominated by iron-rich olivine.
Single stone too.
Yep.
Yeah, beautiful. Nice. Rumuruti.
All right, now we're going to look at the H chondrites. And this one is NWA, the featured one is NWA 16955. It's an H5 chondrite. And the reason I picked this one out is obviously Jason Whitcomb helped me out with this one. But the main mass holders are Tim Moran and Henry Milson. And both of them, this is their first time in the MetBull. So I thought that was really exciting. Tim Moran actually was a recent customer of ours, and I got to know him a little bit, and he put a really wonderful review on our Facebook page, and he really liked a lot of the extras that we put in the package, and wrote to us and told us how excited he was to actually have something that his teenage sons were interested in talking about, because once teenagers, they don't want to talk to their parents that much, but they all actually talked about Chelyabinks and meteorites for a while, and he told me how excited he was to have that, share that with his son. So I thought that was really neat. Anyway, so this is an H5. It has a low shock at S1 and a very low weathering, W 0.0. So as Jason said, this one is freshy fresh. So Jason was offered a few pieces of this, and then over time more trickled in. And then Henry and Tim subsequently purchased the specimens from Jason. Tim took the lead in contacting Dr. Chris Hurd in order to get it classified. And then Dr. Hurd took the mission on and accomplished it quite quickly, getting the meteorite approved and published. And Jason said it was a pleasure to work with everyone involved on this geologically former recent asteroid.
That's majestic. That's awesome. Congratulations, man.
Yes, congratulations, Tim and Henry. Very excited for you guys. This is a new segment I came up with, and I want to actually have this during every MetBull update. And the reason behind this is, obviously, I kind of shared a lot more of the MetBull write-ups this time. I'm trying to understand those a little bit more. So I'm trying to read those while I'm looking at the pictures and trying to understand the descriptions so I can start accurately describing meteorites. And so I read these write-ups and I see these words that I know what they mean, but I don't exactly know what they mean in regards to a chondrule. So every time we have a MetBull update, Professor Pat's going to share a few chondrule terms and tell us what they mean and also show us a picture of it so we can all start understanding these write-ups a little bit better. Pat, take it away.
Yeah, so we talked about chondrules this time, and particularly about petrologic grade and comparing microscopic photos of these. So we're going to talk about well-defined versus not very well-defined chondrules. We're going to talk about the matrix in between the chondrules, and we'll talk about one that's near and dear to my heart too, my L3.15. This one, when we first look at it, we see lots of chondrules, but the important thing to zoom in on is that there's a really nice, thin, very black matrix between each of the chondrules. And this matrix is mostly just trapped dust in the neighborhood when the chondrules accreted into a chondrite meteorite. It's a process we really don't know very much about. But so this one, when I first saw the inside of it, I was very struck and taken with the fact that it has these thin lines of matrix, which generally tells you that it's a type 3 and 3.5 or below. The petrologic grade, everything starts at 3.00, and then with accumulated time under heat and pressure, there is a solid state recrystallization process that goes on that crystallizes the matrix first, and then robs mostly olivine and pyroxene from the chondrules, and the chondrules become progressively less well defined, and the matrix grows, literally, and is very crystalline. So this next one here is one that I haven't classified yet, and not real excited about classifying because I'm looking for type 3s, and once in a while I find a dud. But in this one, you can definitely see some chondrules, but notice how the outline of them are kind of fuzzy, especially the smaller chondrules. And then the matrix, which here is mostly that sort of dusty orange color, that is the matrix that is recrystallizing and so this is solid state recrystallization. So there's not wholesale melting. It's just the molecules moving from the chondrules into the matrix, joining up with other molecules of olivine and pyroxene and forming crystals in the matrix. So this one, lots of matrix, and the chondrules not well defined, total absence of those black thin lines of matrix.
So Pat, when you're describing recrystallization, that is two different items recrystallizing together to form a new matrix.
It's individual molecules of the silicates of pyroxene and olivine leaving the chondrule and joining up with other molecules of the silicates in the matrix, and resulting in kind of an overall messy look here.
I'm glad you described it as not coming from shock or melt, because that's normally what I would think of as recrystallization be the genesis of.
Right. And so melting and shock are relatively fast processes. This solid state recrystallization is an extremely slow process. So we're going to look at one more here. And this one, if you squint, you can kind of see some chondrules, but they do not have defined edges at all. The chondrules that are semi-identifiable are very sparse. And so this one has been extensively recrystallized. So it spent, billions of years buried inside its parent body, or parent planetesimal, and allowed lots of this solid state recrystallization. And if you go even further than this, you can hit petrological grade 7. And in 7, the chondrules are not recognizable at all. Even if you squint, it's pretty much all just recrystallized stuff.
Fantastic examples and explanation. Thank you. This is the L6 one. So you can see very little chondrule formation. In the L4-5, you definitely see a lot more chondrule formation, but there's nothing like this. Was this 3.15, you say?
This one is a 3.15, yes.
Yeah. So that's fantastic. Thank you very much, Professor Pat. Honorary Professor Pat. I know you want us to say that every time.
All right, thank you.
So I want to say thank you, Pat, and definitely stay tuned for future MetBull updates, because I will say I don't know what Pat was like when someone would give him a honey-do list of, if it's like fix this in the garage or, fix that in the car. But if you give Pat a honey-do list that's related to meteorites, this dude is right on it. I mean, he takes it and he runs with it. And he already has started a whole glossary of meteorite terms to discuss on future MetBull updates. So I'm excited to learn more, Pat. Thank you so much. And thanks for always doing such a great job and putting forth 200% every time. So thank you.
Thank you, Sue.
All right. So we're looking at L-chondrite numbers. And the featured one that I would like to talk about is Akebayi 003. And this is an L3 chondrite that was found in Xinjiang, China. And this one shows well-defined, now we know what that means, unequilibrated chondrules containing devitrified glass. They're set in a fine-grained matrix containing camosite, which has been extensively altered to iron oxides, trowelite, and chromite.
And I'm glad you pointed out that you are going to be reading and including more information directly from the MetBull. And Pat, this goes to our conversation we had last week. We're going to be putting out more information of decoding the MetBull. So there's a lot of times we look at the MetBull and you go there for a certain fact or a piece of data and you get it and you leave. Other times you're looking for the story or petrology or geochemistry. There's other levels. There's so much more information there that we get to a point and we skip over and just go to what we want, or it's so scientific that I can't read the formulations. I have no idea what they're talking about. Or you hear a word like unequilibrated and you think, oh, I know what that means. Well, describe it then. Like, I can't. So that's one thing that we're going to be working on. So if you notice, Sue included a lot more of the jargon, scientific jargon in this, and we want to make that our vernacular. Wow. See?
And I mispronounced it just like I knew I would.
Yeah.
Unequilibrated. That's the word. Maybe Pat can tell us a little bit more about unequilibrated next time.
Yeah.
Or this time.
For the future, unequilibrated is a $10 word for type 3. It just means that the rock hasn't been averaged out very much. And so that solid state recrystallization is the mechanism for that averaging out. So anything 4 and above is equilibrated. Type 3s are unequilibrated.
Okay, thank you, Pat. All right, so before we jump into the LLs, I wanted to draw your attention to the last one on this list. And this is kind of going back to what Mike had talked about earlier about, he mentioned an L/H. There are different classifications in the MetBull that are like in between. And when you have an LL and then an L in parentheses, what that means is it's an ordinary chondrite from either the LL group or less likely the L group. That is a petrologic type 3. So if it was the other way around, there are ones that are L and then the LLs in parentheses. It's kind of in between, but more likely it's the L, whichever one is first. So just wanted to point out what that meant. But the one that the featured LL that we're going to look at is actually just an LL3. It's NWA 16519. And this was another one that brought to us from Jason Whitcomb. And so this one is, the saw cut faces are a little bit rough, which Jason thought kind of hides how nice this meteorite will look when it is actually polished up. It is a nice, mostly fresh LL3 with a very colorful presentation. And also something else that Jason pointed out, even though it's an LL3, if you do look it up in the MetBull, Dr. Hurd actually took the time to subtype it to an estimated 3.4, which that effort's always appreciated when the classifiers do that.
And Sue, let me interject for 1 second. You mentioned subtyping, so I'm going to go into what I held off, but you had to bring up subtyping. If we're looking at this little chart right here, you see it goes from L3 all the way to 7. So the more and more altered it is. You can see that there are what Mike alluded to earlier of these that are inclusive. They have LL3 and LL5, perhaps even LL4 in it. Same thing with this. This is a big gap right here. But if you notice, this is a LL3 point. Well, this is what subtyping is. And this is going to hurt Pat the way I summarize this so blatantly. There is no need to really figure out what a petrology is, that number 3 through 7 is, to the decimal point, other than the threes. Once they get to the 3, he says they're equilibrated. So they're not even part of this anymore. So subtyping only takes part on those unequilibrated meteorites. And it's done by measuring chromium in the olivine, I hope, and one of those measurements. And what it does is it puts a subtyping, there's a factor of 10 between 3 and 4 and 4 and 5. And what the subtyping does is it gets that 3 and breaks into 3.1, 3.2, 3.3, all the way up. So it's really only done on LL or on L or on 3 type material is the only time you're going to see a point something. So you might see a 5-6, but you're going to see a 6 point whatever. It's just not done.
Okay, so now we're going to look at irons and stony irons. All right, so as you can see, there weren't too many of these, but one thing I wanted to point out, we talked about earlier, was the ungrouped pallasite, and that was Khatgal. And so I wanted to play a little game. I want to do a little bit of test your knowledge. So this is one where we're going to have you raise your electronic hand. And I know that a few of you know at least one of these. So Khatgal was the 13th ungrouped pallasite approved and added to the MetBull. Out of those 13, I know we don't know all the names of those. Some of them I looked at and I thought I never have heard of that one. But there are other ones that we know, like LBO 002. There were definitely 3 that stood out. They were found in the United States. So do not go to the next slide, Topher.
I know one.
Raise your electronic hand if you know one of the 3 ungrouped pallasites found in the United States.
Allison has her hand up.
Oh, I know Allison knows one for sure.
Allison, what do you know?
It's pronounced Shoto. It's the Shoto pallasite, and it fell in Shoto, Montana.
Yes.
Nice.
Extra bonus points if you know what year it fell or was found.
2013, 2012, 2000.
So close. 2011.
There we go.
All right.
Nice.
Anybody else know one?
Art, there was one, I believe.
Yeah, Albin.
No.
ALBON.
Nope.
Albin, I believe, is just a pallasite main group.
Oh, Mike Kelly has one.
Don't feel bad, Art. Topher guessed Albin as well.
I guessed Albin too.
Mike Kelly.
Vermilion?
Correct. Do you know where that was found?
Kansas.
Correct.
Wow.
Wow. Does anybody know what year vermilion was found? I know that's really
Striking out
reaching.
there.
Yeah.
1999. There's one more. Jim Shelton. Is Jim Shelton here?
Yeah, Jim Shelton. Come on, you're
Come
letting us
on,
down,
Jim.
Missouri man. That should give you a hint. It's from Missouri.
Sorry, I'm coming up blank.
And we're not
my
going
goodness.
on with the presentation until you answer the question.
Oh, no.
I actually said the answer to Sue earlier. I said Vermilton,
Yeah.
which is Vermilion and Milton together. So I get 2 points for one answer.
Milton, huh?
There we go.
Milton, found in Missouri in 2000.
Nice.
All right, and one thing I wanted to mention earlier when I was presenting Khatgal, but I didn't want to give away one of the answers, is that's obviously it's an ungrouped, and what made it different than the other Pallasites was the gallium and germanium ratio. They reflect closest to the vermilion grouplet. All right, so we're going to our last featured meteorite of the night, and that is NWA 16702, and that's an iron 2AB. And this one was sent to us from Yang, and I'll be honest, I'm not exactly sure why it was classified as an iron 2AB. It seems really different than the other ones in that classification. So this is an iron meteorite without a Widmanstätten pattern. It's a hexahedrite. It has multiple well-developed Newman bands. The anomalous properties of this meteorite are that the nickel is low and the gallium is high compared to other members of the 2AB group. I thought the little slices that he had in one of the other pictures is really cool looking.
Yeah, I want to point out some things that I see in this that I want to make sure people understand. These lines right here, these are the Newman lines. These are not saw marks as we would normally see in an iron meteorite. When you see that, your mind immediately goes to an unpolished cutting surface. That is not true in this case. This is an internal structure of the metal. Instead of having the Widmanstätten pattern that, see how I did that, baby?
Yeah.
Instead of having that, the pattern with, it has the Newman lines instead. It's a different chemistry that causes it. It's the difference in nickel that does this. But this also has Schreibersite in as well. Those patches right inside here. I don't know what they're banded with, so it's a pretty interesting sample. And I'm glad that Yang was able to get it classified.
Yeah, definitely. Well, yes, I did mispronounce that. I mispronounced a few words. I knew it, this really heavy petrologic, petrography laden MetBull update that, and me being a fast talker, that I was going to mispronounce a few words, but hopefully I didn't do too badly. But anyways, thank you so much for watching, and we'll see you next time when we will be reviewing meteorites that are approved and published for September and October. So thank you so much.
Yeah, we sure appreciate it. We know you work super hard on these, and I think the crew really enjoys them. I know the YouTube audience really appreciates it. It's a way of keeping in touch with all the newest science and meteorites in one half-hour, 45-minute, hour, whatever we're running block. So if you're one of our supporters on YouTube or on Patreon, we really super appreciate it. You're one of the few. You're one of the magnificent, and so are we. Have a great week, guys. Bye-bye.